This is 6-4, Properties of Special Parallelograms. Pause the video, try the warm-up, and hit play when you're ready. So start. Here are the answers to the warm-up. Number 1, x equals 4. Number 2, x equals 47. Number 3, CD is 14. And number 4, measure of angle C is 104 degrees. Here are some properties of rectangles that we need to know. If you have a rectangle, then it's automatically a parallelogram. And if you have a rectangle, then the diagonals are congruent. In a parallelogram, the diagonals bisected each other, but they weren't necessarily congruent. But now in a rectangle, they're congruent. So let's see what we know so far. A woodworker constructs a rectangular picture frame so that JK equals 50 centimeters and JL is 86 centimeters. Remember, diagonals are congruent, and then all other rules of parallelograms apply at this point. So find the length of HM. Well, since they're congruent, then KM is equal to 86 centimeters, and since it's a parallelogram and diagonals bisect each other, then we know that HM would be half of 86, which is 43 centimeters. Okay, now you try. An artist connects stained glass pictures with lead strips. In this rectangular window, the strips are cut so that FG is equal to 24 inches, and FH, the diagonal, is 34 inches. Find JG. J is the center, it looks like I blocked it. So JG is going to be 1/2 of 34, which is 17 inches. Okay, now let's learn about a rhombus. A rhombus is another special quadrilateral. It is a quadrilateral that has 4 congruent sides. So it's like a square almost that's been tipped though. We've got the 4 congruent sides that's been tipped. So if you have a rhombus, then we already know it's a parallelogram. So it meets all qualifications or characteristics of a parallelogram. Also, in addition to that, if you have a rhombus, then the diagonals are perpendicular to each other, meaning that they form right angles. We also have, if you have a rhombus, then each diagonal bisects its opposite angles. So if this angle right here is 100 degrees, then I know if the whole angle is 100 degrees, then I know that angle 1's 50 and angle 2's 50 because it bisects. So let's apply some of those to calculate some of these measurements. So a rhombus is a parallelogram, so we can use the properties of parallelograms when working with rhombuses, just like we can with rectangles. So TVWX is my rhombus, and I want to find the length of TV. TV, this length right here. Well, don't forget that I know that since it's a rhombus, these are right angles, so I've got some right triangles here. So that will help us. Also, what I just drew, that 14a plus 20 is going to be equal to 90 degrees. So I can already just set that equal to 90 before I even know what I'm solving for. So then subtract 20 from both sides, so 14a equals 70. And so therefore a is 5. 50, 20, 70. So a is 5, which means that I can find this little angle, angle XTZ, because that's 5 times 5, which is 25, minus 5 is 20 degrees. And that means the large angle would be 40 degrees. So let's see, what's this asking for? TV, I still have yet to do anything about TV. So hold that thought. Okay, and then measure of angle VTZ. VTZ. Well, it's congruent to XTZ, which I said was 20 degrees. So it is also 20 degrees. So that helps. We've got that angle is 20 degrees. Alright, so what do I know about side lengths of a rhombus? Well, they're congruent to each other. All of these are congruent to each other. So I can actually set the 3b plus 4 equal to 13b minus 9. So I can subtract 3b from both sides, and while I'm at it, I'll add 9 to both sides. So I get 13 equals 10b. Do I like that? I guess that's going to have to be what it is. Divide both sides by 10, so b equals 1 3/10, or 1.3. Okay, and if I plug that 1.3 in, so if I find like side xt, for instance, and I do 3b plus 4, so 3 times 1.3 plus 4, well, that's 3.9 plus 4, 3.9, yep, and that is 7.9. So xt is 7.9, which also means that tv is the same thing because all the sides are congruent since it's a rhombus. Okay, another rhombus, and it's asking for a side length vt, so I'm going to keep in mind that all my side lengths are congruent, so I can set 4x plus 7 equal to 9x minus 11. I can subtract 4x from both sides. I can also add 11 to both sides, and I end up with 18 equals 5x. Divide both sides by 5, and that is 5 goes into 18 3 times with 3 left over, so 3 3/5 or 3.6. Okay, so I can find VT just by plugging that in. So 4 times 3.6 plus 7. So VT equals 21.4. Okay, RSTV is a rhombus. Find the measure of angle WSR. So this angle right here. Well, I'm already marking. I see that 2i plus 10 is pointing towards the middle, and I know that those diagonals are perpendicular, so therefore it's 90 degrees. So 2y plus 10 is 90 degrees. Subtract 10 from both sides, so 2y is 80 and y is 40, which means that this angle y plus 2 is 42 degrees, but these are congruent because the diagonals bisect the angle, so it creates two congruent angles. So WSR, measure of angle WSR, is equal to 42 degrees. Okay, this is kind of a lengthy problem. So we want to show that the diagonals of a square are congruent perpendicular bisectors of each other. So the diagonals, well, the first thing, to show that they are congruent, we would need distance formula because we want to see the length of them. So I take my 2 points, x2 minus x1, which is 2 minus negative 1 squared, plus y2 minus y1, 7 minus 0 squared. Let me mark what I'm actually finding instead of just distance. I'm finding the length right now of AC. Okay, so AC equals, well, 2 minus 1 minus negative 1 is 3 squared. So that's 9. 3 squared is 9, plus 7 squared is 49. And that equals 49 and 9 is 58. So AC is radical 58. And we could try to simplify that. And then also I need to know the length of BD. So I'm doing the same exact thing. So negative 3 minus 4 squared plus 5 minus 2 squared. Okay, negative 3 minus 4 is negative 7 squared, which is 49, plus 5 minus 2 is 3 squared, which is 9. So those are congruent because they're the same measurement. So BD is radical 58 and AC is 58. So they are congruent. So I've taken care of the first word. They're congruent. And I did that using distance formula. Next, I want to see if they're perpendicular. That's the second word. Perpendicular. Well, to see if something's perpendicular, I need the slope to see if they're negative reciprocals. So I'm going to take the slope of CD, or AC, sorry. AC, slope is y2 minus y1 over x2 minus x1. So that would be 7 minus 0, which is 7, over 2 minus negative 1, which is 3. And now I'm going to find the slope of BD. Same thing, y2 minus y1, so that's 5 minus 2, which is 3, over negative 3 minus 4 is negative 7. Well, these are negative reciprocals of each other. So this is perpendicular. So they're congruent, perpendicular, and now bisectors. To see if something's a bisector, I need to make sure that the midpoint for both of them is the same. So for bisectors, I'm looking at midpoint. Well, midpoint, remember, is a big ordered pair. It's x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So let's do that for AC first. AC's midpoint, what we would do, the x's added together, negative 1 plus 2, which is 1 over 2, comma, and then add the y, 7 plus 0 divided by 2. Now let's do the same for BD. The midpoint of BD, we do negative 3 plus 4, which is 1 divided by 2, and 5 plus 2 is 7 divided by 2. So these are the same. So therefore, I have shown that the diagonals are congruent, perpendicular bisectors of each other. Again, to see if they're congruent, you use distance formula. To see if they're perpendicular, you check the slopes of both diagonals. And to see if they're bisectors, you check the midpoint of both diagonals.